Welcome everybody. My name is Tolga Tarhan. I'm the CTO for Sturdy. We're an Amazon partner in Southern California, focused on DevOps and application development in AWS. And today we're going to talk through sort of how AWS pricing works and make sure that everybody starts with a good baseline for understanding how AWS actually prices their products. Then we're going to go into monitoring and controlling your costs with a handful of first-party tools, and then I'll show you briefly one third-party tool to give you a flavor of what that's like. And then at the end, I think the part you all really want to talk about today is how do we reduce our costs in AWS? How do we maximize the value of the platform? And I'm going to go through about 10 sort of tips on how to do that. So kind of jumping right into it, let's talk about Amazon's pay-as-you-go model. As you guys know, most AWS services are kind of consumption-based. You only pay for what you use. And specifically, they tend to have two billing metrics. There is some kind of consumption metric, and then there's some kind of time metric. So what I mean by that is take the most simple case of an EC2 instance. There are different types and sizes of instances. That's the consumption metric, is how big is your instance. And then the time metric is seconds. It used to be hours. It was brought down to seconds recently, meaning for every hour that your instance is running, based on the size of your instance, you're going to pay some per second fee. Now you'll notice when they publish these rates, they're published as per hour rates. You just divide them into minutes and seconds to get down to the actual per second cost. EBS volumes, very similar story. You pick an amount of storage that you want to pre-provision, and you pay per second. What's unique about both of those first two cases is that they are based on provisioned capacity, meaning you choose the instance size and the storage size before you start, and you're paying for them whether they're utilized or not. And this is where Lambda is really different. Lambda, as an example of something that's sort of truly usage-based, it only runs in these 100 millisecond increments. And so as a result, there's not really any pre-provisioned capacity at all. And in that case, you really don't have the scenario of underutilized resources. Now, turning our attention to a totally different kind of example, Chime, which we're all using here today for this call. Chime is charged per month. So there are some services where the fee is actually at the month level, meaning as soon as you increase the number of users in a given month, you're going to pay for that increased number of users until the next month. And then I give these last two examples as another sort of example of sort of pure consumption-based. S3 does not have pre-provisioned storage. You just use the storage that you use. And in the case of standard storage, which is what everyone thinks of S3 as being, you pay by the hour. And again, the rate here that you see on the website is per gigabyte per month. So you have to divide that out into days and hours to get the actual per hour cost of each gig. And further, you have to divide gigs into megs and kilobytes and bytes to get the actual per byte cost per hour, which is what you're actually paying for. And then the kind of on the contrary, if you look at S3 IA storage, which is infrequently accessed storage, here we've got kind of the same metric of gigabytes, but we have a 30-day minimum. So when we put something into infrequently accessed, we will pay for that object for 30 days, even if we delete it before then. So there are a lot of different time metrics, and there are a lot of different consumption metrics, and the permutations are quite vast. This is perhaps what makes AWS pricing complicated, and this is where understanding the metrics can make a big difference. So to kind of finish this thought, the most common time metric is per hour. It's pretty rare that we see other variations. Recently, we're seeing more and more of the per second metrics, but it's very rare to see like that monthly metric. I threw one in there just as an example, but by and large, it's going to be per hour or per second. The benefits of this model are that we can easily experiment. It costs almost no expense at all to run an experiment for a couple hours, or to explore or play or develop and innovate. So the cost of development is very, very low. The barrier of entry is very, very low because we're not pre-provisioning resources. We're not having to make a choice about how many servers we need or what size they should be. We can just change that over time and pay for what we need. It's also fundamentally easy to understand. You just multiply these two columns together, and you understand what you're paying for. The complexity, of course, is just the permutation explosion that happens, which I'll show you in a minute. And then it's relatively easy to control because everything is kind of per hour or less. When you shut something down or delete some resource, the effect is immediate. You stop spending that money right then. And so you can, even midway through the month, take actions that dramatically impact what your bill looks like at the end of the month. You don't have this long cycle to wait for a whole nother bill before you see the impact. Okay, so here we're going to jump kind of into the monitoring and controlling costs. These are going to be about how we understand and keep an eye on what our costs are doing. And we're going to focus mostly on the AWS tooling here, but again, I will show you and give you some names of third-party tools as well. So first of all, what you're seeing here is the AWS management console. And in that console, in the menu in the upper right there, there's the billing dashboard. So that's the start for all these tools you're going to see me show you. That's where you go. On that billing console, there's a left bar with all these items, and the items that have the red box around them are the ones we're going to talk about today. So I'm going to go into each of those and show you an example of what it looks like and show you how you can use that tool. Starting with the bill. So here is a partial month bill for November. So I took the screenshot yesterday, so this was just 1 day of usage at the time. And what you can see here is there's a breakdown by service. You can see there's a bunch of services in this account. The screenshot's actually cut off. There are more services below the fold there. But the very first thing I do when I'm analyzing someone's AWS spend is actually look at this bill, typically for the last complete month, and at least zoom in on what service it is that's got the largest dollar spend, right? It's an obvious target is to start with the service that you're spending the most with. Typically, it'll be EC2. That's very common. It'll be EC2 because that's the workhorse of the fleet. That's where you're going to run all your VMs. So unless your application is kind of moved on to the pure serverless model, odds are you've got EC2 instances running, and it's a substantial part of your deployment. So once you zoom into a service, you see that it's broken down by region. So this gives you another opportunity to zoom into what region might be taking the most cost. In this particular account, the screenshot is from like a lab account where people are experimenting all over the place. I bet for most of you, you'll see all your usage in one region. Then when you dig one level deeper, so I've zoomed in now into the region. So now we're looking at EC2 usage in a single region. You get down to the individual line items, right? And so I'll just call your attention to, for example, the second block of hours there, where we're seeing some T2 micro instances for 76 hours, and we're seeing M3 extra large reservations being applied. And I'm going to talk a lot about reservations in a minute, but this effectively shows you how the line, sort of the SKU level detail of how your bill is constructed, the number of hours, the number of gigs, whatever the metric is, the number of I/O requests in the case of EBS, all of that is in here. This can be somewhat difficult to make sense of at first. I would tell you to go look for, again, the biggest number. Like in this particular screen, I'd zoom right in on the $24 for EC2 Windows, and then I would notice that I've got M4 2X larges running for 18 hours, which is probably essentially full time, given that I took the screenshot yesterday. So we incurred $13 in a day of this M4 2X large. That gives me something to go look for. I can now go look in the console and say, like, where am I running these instances, and do I need them? And so I would encourage you to start with the largest dollars first and work your way down when you're attacking it from this angle. Now, maybe a more productive way to approach it is this tool called Cost Explorer, which is the second tab on the console. Cost Explorer has become quite a powerful tool over time. It now has the ability to sort of slice and dice data by all these metrics you see on the right that they're unfiltered on the screenshot. And what you can see here is this is a really clear way to see what service is driving most of my usage. You can see like looking back at September, we see a lot of EC2 and we see a lot of other, which is to say not one of the services listed there. You can drill into those and see what those services are. There's a table below that shows it in kind of a tabular format. And then this also has the ability to forecast. So here's an example of forecasting where based on usage from May through October, the November bill has actually been forecast for you by this tool. You can see in the table below where it's got 2 stars next to November 3rd and November 4th. What it's telling you there is that those are forecasted numbers. And then one more sort of screenshot to do justice to Cost Explorer. Here's a zoomed in, like I zoomed in just from October 24th to the end of November to get forecast spend. You can see here very clearly where there's actually 85% and 80% confidence bars with an actual forecast in the middle of those two. So this is going to give you an idea of what the invoice would be if we continued the usage patterns from months before. You'll notice that oddly, in this case, it kind of goes up from the beginning of the month to the end of the month, and that's because if you remember back in our sort of source data, that's the pattern. Like the pattern since May is that our usage increases later in the month relative to the beginning of the month. What's driving that pattern is worthy of investigation. In this case, this is again a lab account, so it's really just a continuous climb, as you can see, of spend. But this is going to again help you A, forecast, and B, understand what service to target. At the end of the day, once you get down to sort of a service that you need to investigate, you're going to go in the console and you're going to go look for that service. I'll show you a couple other tools there, but the purpose of these exploration tools is mostly to figure out where the spend's going. To actually control the spend, we're going to have to go make changes to the service. Moving on now to budgets. There is a built-in feature called budgets. You can set spend limits by service and by tag. I will talk a lot more about tags when we talk about cost control. But the bottom line here is that we can get email alerts when the budget is breached or when we forecast to breach it, which is really handy because if you think about a monthly limit, if you say I want to spend $1,000 a month on EC2 instances, and let's say something happens where your monthly usage doubles, you might not actually exceed your budget till midway through the month. But if you are monitoring the forecast spend, you would see that happen right away. You would see that the forecast increased right away. I just took a couple screenshots of the kind of choices you can make in a budget. So they can be based on cost or usage or reserved instance utilization, which we'll talk more about in a minute. And you can filter by these kind of concepts on the right side. So by tags or by sub-account or by service, by availability zones, all that kind of stuff. Moving on to the cost and usage reports. So cost and usage reports are the detailed billing records. There actually used to be a report that's still available that's actually called the detailed billing report, but the new replacement for that is this CUR report. The CUR reports are customizable and you can get them by hour or by day. You can control the format they're in and you can have them imported to Redshift automatically as well. These records are like the raw usage records that comprise your bill. So your bill is a summation of these individual records. The most useful way to utilize these records is either with a third-party tool that can analyze them or importing them into Redshift and running analytics on them yourself, like with Tableau or with QuickSight. This is very granular data here. Okay. The final area I want to talk about in the AWS kind of monitoring tools has to do with tags. Tags are a concept that exists throughout AWS. You can tag resources in EC2. You can tag resources in probably half the services at this point. Tags are just name value pairs. So the name of a tag is something you make up, and the value of a tag is something you make up. But the point is to pick a few tag names that you're using over and over again. So like these three here are super common for us. The application, the company, if you have like sort of multiple business units that are operating under one account, and the environment, like dev versus prod versus stage. So you can take a subset of your tags that you're using in your normal resource management and make them billing tags. All that means that these tags become part of the detailed billing reports that you get. Nothing changes in the way the tags work outside of the billing system. So you still can use these tags and other tags in managing your resources, managing IAM permissions, and for all the other uses of tags. But the ones you list here will have the additional value of being included in the billing reports. A lot of times, if you're exploring these costs, this is super handy. And enabling a tag here also enables it to be used in Cost Explorer for refining your view of the spend. So if you wanted to kind of see how much you're spending for application A versus application B, or for dev versus prod, enabling these kind of tags would do that. So then there's a bunch of third-party tools. I listed three sort of ones that are in the sphere that I've run into recently, but there's dozens of others. And I'll show you some screenshots from the first tool. So we have a partnership with CloudCheckr. We utilize CloudCheckr on all the accounts that we manage. It looks like this. This is just one screen from CloudCheckr showing cost-saving suggestions. So I just kind of picked an account at random here, but you can see that according to CloudCheckr, there are 2 resources that are idle. They're not being utilized. So we could delete those instances and save some money. And there's also sort of 7 instances where we could buy reservations and save some money. And again, I'll talk about reservations more in a minute. But essentially, the thing about CloudCheckr over the built-in tooling is that it'll make specific recommendations. It'll actually say, go do X, and you'll save this much. Now, it still requires a human to evaluate if that's a wise thing to do or not. But that is a benefit of CloudCheckr. Here's just another view. This looks a lot like the Cost Explorer that we saw in the AWS tooling, their own take on it. I just hovered over a day, and you can see for that day for EC2, it showed me sort of what comprised our EC2 cost, and it kind of does a stack graph of it. You'll notice the top 2, the word unblended under cost type. You have the option in CloudCheckr to look at blended or unblended pricing. When we talk about reservations, I'll talk more about that price blending piece. Okay, so that was sort of the 20-minute intro to how does AWS pricing work, and what tools can we use to take a look at what our current spend is, and how do we get alerts from budgets. Now we're going to talk about how we reduce costs. A lot of people call this controlling costs, but I want to be more honest with ourselves. The goal is to reduce your AWS spend most of the time. So I have a slide or 2 on each of these items. We're going to talk about them, and hopefully there are some tips and tricks here that are new. They kind of start from the easiest win to the most challenging. So one of the easiest things you can do is make sure you're using consolidated billing. It's also known now as AWS organizations. This is where you have multiple accounts billed to a single payer account. So if you today are operating under like 4 different AWS accounts, maybe for dev versus production, or maybe for different business units, you should definitely get them under one payer. In addition to being more convenient from sort of a billing point of view, you get to share volume discounts. Volume discounts are for items such as data transfer. If you look at the pricing for data transfer, you'll notice that you get actually discounts as you do more and more data transfer. With consolidated billing, your combined usage will apply to the usage discount. So whereas if you might have enough usage across your 4 accounts to reach a discount tier, but not enough for any one account to reach the tier by itself, by combining them, you will take advantage of the discount tier. The other really valuable benefit is sharing reserved instances. So when we talk about reserved instances, I'll talk a little more about this, but the important takeaway here is that if you buy a reservation in one account and that account doesn't utilize it, another account can utilize that reservation, allowing you to sort of more flexibly manage your reservations. You could also choose just to buy all the reservations in one account and let them flow down however they need to. Okay. The next easiest thing to do is dealing with idle and unused resources. This is one of these points that's actually kind of really obvious, but you can't believe the number of environments where this is the major sort of source of unnecessary spend. So a lot of times this comes from development usage where developers will spin something up and they won't turn it down. It happens even in sort of our own accounts with a team full of experts. The reality is here that the main way to control this is a good tagging policy. Every instance that's created, especially in a dev account, should be attributed to what it's being used for and how long it's expected to stick around. So if I'm doing an experiment using Redshift, I should indicate that like this is a 1-week experiment in Redshift. And if somebody looks at that tag later, it's been 2 months, that should raise an eyebrow. We can monitor this kind of growth with CloudWatch or with third-party tools you saw, like CloudCheckr. But the bottom line here is be mindful of idle and unused resources. It's a source of cost growth that we see a lot, and you need some discipline around it to both prevent it from happening and then to also find and resolve it. The next thing is about having the right service. So there is more than one AWS service for any given job, and you need to make sure you use the right service. This can make a big difference in the price that you pay. One of the lessons learned early on for me in AWS is if the bill feels unreasonable relative to the work you're accomplishing for that amount of money, it probably means you're using the wrong service the wrong way. Most of the time, the services are very cost effective when used for their expected purpose. So the first question to ask yourself is this the right service? That first example there of Lambda versus EC2 might be the most sort of prolific example. It's also the most extreme example in that an application that exists today that's migrating to the cloud isn't going to move from EC2 to Lambda. That's a tall order. But a net new application could be developed as a traditional web app on EC2, or it could be developed as a serverless app on Lambda. The cost difference between those two services is extreme. And so you would see a very significant difference in overall cost based on the choice you made there. RDS versus EC2, this is a little bit of a trickier example. Normally you want to use RDS because it adds a lot of value. It does add more cost, but when you look at the extra value you get in RDS and trying to replicate that in EC2, you actually find that you'll spend more on EC2. We see this a lot with SQL Server, where setting up sort of SQL Server mirroring requires more resources on EC2 than it does in RDS. And then the last one is I think a really good, simple example. POps is provisioned IOPS. So when you have a volume on EBS, you can either have it be general purpose, or among other things, you can have it be provisioned IOPS, where you're getting a throughput guarantee. You're saying, I want to be able to do a certain amount of I/O on this volume. This is probably like the most egregious premature optimization that I've seen. You don't probably want to start with provisioned IOPS. They're very expensive, and now you're paying for I/O you might not actually be using. You're just estimating, you're forecasting your I/O needs. It'd be better to switch to provisioned IOPS in response to general purpose not working well, right? You start with general purpose. So again, this is a matter of, did I pick the right service? Did I really need provisioned IOPS EBS, for example? So if you have the right service, then the next question is, do you have the right size? The tendency in AWS is to over-provision. In fact, I guess that's the tendency outside of AWS as well. This makes sense when you're building a data center because you don't have time to get more hardware if your load spikes. That's not the case in AWS. Launching more instances is easy and quick. So, and changing the size of instances is easy and quick. So what we should be doing is benchmarking our workloads on smaller instances. So the way AWS pricing scales on EC2 specifically is about twice the cost for each size increase. Right? So an M4 large is 10 cents an hour, An M4 extra large is 20 cents an hour. If you look at the CPU and memory between these two, they're also exactly double. So you get exactly double the resource for exactly double the cost. It scales linearly within an instance family. So the first question to ask yourself is, if the workload performs well on extra large, you might try a large and see how your workload performs. You need to kind of do some data-driven decision making as opposed to assumptions around the resource needs. The next one, so you've got the right service, you've got the right size. Do you have the right quantity of the thing you're provisioning? Probably instances in this case. There's this general concept of consumption-based versus forecast-based. In the traditional way we ran IT organizations, we would determine the number of instances that we need based on a forecast. But in AWS, we really should be doing that based on what we're consuming. We should be responding to CPU, memory, and other statistics and adding instances to meet the desired sort of metrics around those parameters. This is again about being data-driven and not over-provisioning based on a forecast. What helps with this a lot is a tool called autoscaling, which can keep a group of instances running, replace failed instances automatically, balance them across availability zones, and then give us that sort of metric-driven scaling. We can do CPU-based scaling, for example, and say, if the CPU load is above a certain value for a certain period of time, then add more instances. And if the CPU drops below a certain value for a certain period of time, let's remove some instances. And this gives you sort of automatic, data-driven. There's no need to sort of forecast. It doesn't mean that we don't responsibly forecast for budget purposes, but it does mean that we shouldn't apply that budgetary forecast against the actual infrastructure. We shouldn't, just because the budget says we have enough money to run 10 instances, doesn't mean we need to run 10 instances. So the next one is time-based management. So this is one of these scenarios that I think surprisingly few people are taking advantage of. There is only 25% of the week where people are working for a sort of a standard 8-hour day, right? So 40 out of 168 hours are work hours. So for these non-prod environments, QA, dev, integration, if they're not being utilized at night, if they're not being utilized on weekends, we just don't run them during those times. And we could save 75% just by doing that. You can automate their shutdown, automate their startup. Even if we could get 50% here, this would be a huge, huge savings. If you could save 50% and have no impact because no one's using the instances anyway, that's pretty significant. And then for prod environments, if you can't do the metric-based scaling I talked about on the last slide, you might at least be able to do time-based scaling for your prod environments, meaning you know that you've got spiky workloads, you've got a consumer-facing application, so it's busy in the evenings and the mornings, but it's not so busy during the workday. You could, and it's really not busy at all in the middle of the night, you could have automatic scaling up and down based on time. So this applies to both prod and non-prod environments, but maybe in slightly different ways. Okay, we've gotten past the simple discussion, and now we're going to go into the more complex part. Reserved instances. This is perhaps the single most misunderstood concept in AWS, so I'm going to try to spend a few minutes on the slide explaining how this works. First of all, understand that the discount you can realize is sort of up to about 75%. It could be sort of anywhere from 10% to 75%, depending on the RI that you buy. A reserved instance is two things. It is that discount, and it is maybe a capacity guarantee. This capacity guarantee with the asterisks here, that probably matters more for Netflix than it does for the average environment. But it is an interesting aspect of a reservation. It only applies, though, if you make a reservation for a particular availability zone. So when you go to make a reservation, you can either make one that's kind of regional, or you can make one that's AZ specific. If you make an AZ specific reservation, you get the capacity guarantee along with the discount. If you make a regional reservation, you only get the discount, but not the capacity guarantee. Now, in practice, for environments that are sort of in the hundreds of instances range, the capacity guarantee is I've never seen it be an issue. Okay, so that's what you get. Now, what do you have to do to get these benefits? Well, you have to make a 1 or a 3-year commitment to use a certain resource. The commitment can come in a couple different ways. In the most basic way, what we call no upfront, it's just that. You're just committing to using the resource, but you're not paying anything upfront. You're still paying as you go, but if you don't run the resource, you're going to be billed for it anyway. That's the no upfront version. The partial upfront version says, I'm going to put a down payment down against my future usage. In exchange for that down payment, you're going to get a reduced hourly rate. When you combine the down payment with the reduced hourly rate, you'll have an effective hourly rate, which is discounted relative to the on-demand. Partial upfront will always be more discounted than no upfront. And then the last one is all upfront. This is where you actually pay for the entire consumption period in a lump sum. This gives you the largest discount. There are no hourly fees after you pay this for that instance. But of course, it has the disadvantage perhaps of being capital intensive. For many, many customers, partial upfront hits a really nice sweet spot. Now, there's also an option called convertible. But before I explain convertible, let me explain the limitations of a normal reservation. A normal reservation is tied to an instance family. So if you reserve an M4 large, that's the capacity that you're going to get. You're going to get credit against your RI only when you run an M4 large. You can modify the reservation and make it a different size within M4. Change it to a medium, change it to an extra large. That's allowable in a standard reservation. But at all times, your reservation must match the instance that's running. Otherwise, you don't get the credit. With the convertible option, we take that one step further, and we can actually make it across instance families. So you might reserve an M4 large today, but change it to a totally different instance family, a C3 tomorrow. There are rules about the conversion. There could be additional fees due to the conversion, and your conversion must always be of greater value, meaning you couldn't go from you couldn't go down to a level that has less overall reservation. But it's very, very flexible. It is only available at this point on 3-year reservations. So you make a 3-year reservation, you can get this convertible option. It is still incumbent on you to manage the conversion. So if the reservation is sitting there unutilized, you need to go in and modify the reservation to convert it to another instance family that you can utilize. So that's what conversion's about. Remember, even without convertible, you still can change sizes. Convertible lets you change families. Now, the last 2 bullets apply to all reservations, and they are by far the most misunderstood part of reservations. A reservation is not a particular instance that's running. You can't go to the console and point at an instance and say, this is this reservation. Instead, it's more of a logical concept, meaning if I have 5 reservations for M4 large, and I'm running 7 M4 large instances, 5 of those 7 will get the discount benefit of the reservation, and the other 2 will not. So which 5 it is doesn't matter. I could shut down the one that's currently getting the reservation credit, and another one will get the reservation credit. So there is no need to understand the reservation requirements before you launch your environment. You launch the environment first, you get it stabilized, then you buy reservations to match what you've built. And if you later need to shut something down and replace it with something else, it will just transparently take over the reservation as long as all the parameters of the reservation match the new instance. And this happens hour by hour. So every hour, the reservation could apply to a different instance. Okay, so that's the long speech on reserved instances. Here's what it looks like in the Cost Explorer. The Cost Explorer has the option to go in and look for RI coverage. So what you're seeing here is the blue line are instances that are covered by an RI. The red line is what 100% coverage would look like. In between those two lines is opportunity to save money. If we have a steady state workload, we should work really hard to get the purple line as close to the red line as we can, because that's where every instance that's running is covered by a reservation, and we're going to see the biggest cost savings. So this is the report you use to start exploring what reservations you should buy. At the table at the bottom, you can see the specific reservations that you should probably create. This is the opposite tool. This is RI utilization. So where the other tool is designed to show you where you need to buy more RIs, this tool is designed to show you where you have excess RIs. You can see here it's pretty good. There's not much in the way of excess RIs. The two lines are virtually on top of each other. But you do also see there's an R3 2X large at the very top of the table that has 0% RI utilization. So what that's saying is this reservation exists, you're paying for it or have paid for it, and it is not matching to an instance that's running. So you should either convert or modify that reservation to cover something that is running, or you should go run an R3 2X large if that's what you need to be doing. But that is wasted money right on that line. Okay. So I'm moving on from reservations to perhaps the polar opposite. So reservations are guaranteed capacity, discounts for committing to usage. They're sort of the long-term view. They're the way you express commitment to AWS. Spot is almost the opposite. Spot is excess capacity in AWS that's available for you to bid on. You can run sort of stateless and batch-oriented workloads. If you've got a batch job that can run any time of the day, as long as it runs, twice a week, that's perfect for Spot. You bid a price that's reasonable on the spot market. When that excess capacity is available, your Spot request is fulfilled. The instance runs, does your batch job, and then it's terminated. These Spot requests, you can bid any price you want, but there is historical data that shows the spot prices that you can look at in the console. The important thing to understand is that your instance only runs when the market price is less than your bid. So you'll never pay more than your bid. You might pay less than your bid. You'll pay the current spot market price. When the spot market price goes above your bid, you get a 2-minute warning. So your instance has 2 minutes to wrap up what it's doing before it's terminated. This all results in dramatically lower prices, sometimes incredibly low prices, but it can also lead to actually higher spend. So if you bid above the on-demand price, which is the price you would have paid without Spot, and if the spot market price goes up above the on-demand price, you will pay that higher price. So it's important to sort of manage your bid price as well, and oftentimes important to combine some on-demand with some Spot. The other element to manage with regard to Spot is that your workload can be interrupted, right? You've got this 2-minute warning and you're going to be shut down, and you don't know when you're going to be relaunched again. So this works for workloads that are stateless and interruptible. Spot Fleet makes this a little bit better. So Spot Fleet allows you to take a group of different instance types, map them to capacity, meaning maybe you're saying an M4 large is a capacity unit of 1, and an extra large is a capacity unit of 2 in your application. This is kind of based on your application. Then you just say, I have a desired capacity of 3. And the Spot Fleet figures out which combination of instances can fulfill your request at the most cost-effective manner. So it's kind of like It's kind of like a management layer on top of Spot instances. Okay, so we've reviewed all the sort of standard cost-saving tools. We've reviewed how to manage your bills. One quick slide on sort of what we as Sturdy do. We are a managed DevOps provider. We help customers manage their spend on AWS. We can help you implement all these cost controls I've talked about on an ongoing and recurring basis. We're also a full sort of managed service provider, so beyond cost, just security, provisioning, deployments, DevOps pipelines and automation. That's all included for a fixed monthly fee under our managed service offering.